Hi again. It's Mr. Firth. Did you miss me? So this is 5.2 notes number 2. We will continue to solve systems of equations by using substitution. So solving for one variable and then replacing that in order to solve for the other one. And we're still dealing with the idea of that if we were to graph these equations on a coordinate plane, we're trying to figure out where do the two lines intersect. Where is that point that they have in common? Now the big difference between the previous video versus this one is in the previous video, most of the equations were already in x equals form or y equals form. So you could start the substitution process right away. Well, now as you look at the equations that are on these pages, none of the equations are in x or y equals form. So we're first going to look at, well, how do we rearrange the equation to be able to then start the substitution process. So on number 1, we have these two equations. And so I see right now a coefficient bigger than 1 and coefficient bigger than 1 and a constant number. But down here, well, yes, x and y are on the same side of the equation. The big advantage that I have is look at the coefficients in front. I have a negative 1 in front of the x. I have a positive 1 in front of the y. So it's probably in my best interest to make the y by itself on one side of the equation. Well, in order to do that, I would just have to move the x to the other side. So if I'm going to move the x on the second equation, I add it to itself because I'm doing the opposite operation on the left, and then I have to add it to the right. Now the 5 and the x do not combine to make 5x. Remember, you can't combine constants with variables. But over here, these cancel out, and I'm left with the y. And then over here, I now have a positive x, and the 5 started positive, so it just remains positive. I didn't do anything to the 5. So now I'm in that situation where, oh, I have y by itself, so everything else right here can get substituted into the other equation. Okay? Because remember, we're taking one of the variables in one equation and substituting it into the second equation. I have the value of the variable y, which is x plus 5, and I'm substituting it back into the other equation. So now we're basically right back where we were in notes number 1. So I'm taking this equation and I'm replacing y right here with the x plus 5. And now I'm only working with x's, so I can quickly solve for x. So this is a 2x. I have my distributive property, 2 times x, and then 2 times 5. So that's going to give me plus 2x plus 10, and that is then equal to 10. And then what I have is I have like terms. I have a 2x and a 2x right there and there, and that gives me my 4x plus 10 equals 10. Now you're like, wait a minute, why is there a 10 on both sides? Well, I'm going to subtract this 10 to the other side just like I normally would. And yes, it produces 0. That's okay. Because look what you have here. You have 4x equal to 0. Well, what number times 4? What number times 4 equals 0? 0. So I'm come to the conclusion that x is 0. And now what do I do with this 0? I plug it back in here to figure out what the y value is going to be. Well, yes, there's a negative, but it's just negative 0. Well, that's just 0. So 0 plus y equal to 5, and then that gives me y equals 5. So here is my x value, my y value, for a final answer of 0, 5. All right, in number 2, in the first equation, I see a y by itself. In the second, I shouldn't say by itself, a singular y. And then in the second equation, I see a singular y. So really, either one of these equations would be easy to turn into y equals form. Okay? I'm actually going to choose the second one, and the only reason I'm going to do that is because I know that when I move this negative 2x, when I move it to the other side, it's actually going to become positive. And I'd rather work with positive numbers than negative numbers. So the first thing I'm going to do is add the 2x on the left, add the 2x on the right, and now I'm left with y equals 2x plus 5. And again, I'm at that point, I have y isolated, So this right here is what gets substituted in for y in the other equation. So there's my first substitution for this problem. So I'm doing 3x, no longer plus y, I'm just plussing all of this, or adding all of this. So 2x plus 5 is equal to negative 5. Combine like terms, I get 5x because I have 3x is here and 2x is there. And then plus 5 equals negative 5. I'm subtracting 5 from both sides, so don't make the mistake of thinking the 5 just cancel each other out. I'm actually left with 5x equals negative 10, and then when I divide by 5, I get x equals negative 2. So there's the first part of my answer. Now I take this negative 2, and I'm going to plug it back in here for x, so there's the second substitution of the day, and I'm going to do, or I should say of the problem, so I'm going to do y minus 2, and x is negative 2, equals 5. So now I have y minus, but this is being multiplied, so I have to do this multiplication first. Well, negative 2 times negative 2 is actually positive 4. So I'm at y plus 4 equals 5. Now I'm subtracting 4 on both sides, and I get y equals 1. So I found the x, I used it to find the y, and my final answer, the point of intersection is at 2, 1. Okay, now as we move to number 3 and 4, I want to remind you that most of the time that we are solving systems of equations, there is one solution, one point that belongs to both lines at the same time. But remember, there are two other possibilities. There is the possibility that the lines are actually parallel and they never intersect, so they are no solution. Or the lines start looking like two different equations, but if you go through the process of graphing them, they actually end up being the same line. Well, kind of keep that at the forefront as we go through these next two questions. I'm going to do the same process I just did with the other two questions. I see a singular y, so I'm going to move the 2x's to the other side. They started as plus 2x, so I do the opposite operation. And that gives me y equals negative 2x minus 1. And then this is what I'm going to substitute into y in the first equation. And then we'll follow through with the algebra. So 4x plus 2 times negative 2 minus 1 is equal to 8. And I'm going to work my way through this. So 4x. And then notice that 2 times minus 2x here gives you minus 4x, and 2 times negative 1 gives you minus 2 equals 8. And now I want to combine like terms. Well, if I have a positive 4x and a negative 4x, they cancel each other out. They look at each other and say bye-bye, because positive 4 and negative 4 make 0. So those actually cancel. And now what are you left with? You're left with negative 2 on the left, and positive 8 on the right. That clearly is not a true mathematical situation. Negative 2 does not equal 8. We'll think all the way back to chapter 3 when we first learned about this. In the process of solving equations, if the variables disappear, in which case the x's all went away, if the result is a false statement, in which this is, that would tell us that these equations, or this equation, or these equations as a group, has what? No solution. Okay? If I can't solve for one of the equations, which I couldn't, right? That means there's no way I could solve for the system of equations. So if one equation has no solution, the two of them together have no solution. And why would this be? Because that would imply that they're actually parallel lines. There's no point that they have in common. So we'd say there's no solution to the system of equations. Okay? Now as we look at number 4, I see a fraction. I'm not going to be scared of it. I'm going to be brave. Okay? Fractions are not scary. They can just be a little more difficult to work with. I see a singular y. So I need to move this term to the other side. So it starts as a positive 2/3 x. I'm going to move it to the other side. Negative 2/3 x over there. Subtract 2/3 x over there. And what am I left with? I'm left with y equals negative 2/3 x plus 2. Fractions. Well, we'll do what we can. So y is equal to all of this. So this is what is going to be substituted in for y right here. So let's see what happens. So I'm working with the first equation, 2x plus 3 times everything I'm plugging in for y. So that's negative 2/3 x plus 2 equals to 6. All right, so I see there's some distributive property that needs to happen here. So 2x, and then I have a positive 3 times a negative 2 over 3. Well, this 3 right here times negative 2 is negative 6, and then divided by 3 gives you minus 2. And the x was with it, so it's minus 2x. Okay? And then this 3 times this 2, the other part of distributive property, gives you plus 6 equals to 6. Okay, now again, notice, these x's cancel each other out, because positive 2 minus 2 creates 0. And now I'm left with 6 equal to 6. Well, that is true. Now the left side of my equation is equal to the right side of my equation. That's a true mathematical equation. So, if that's true, that means any value of x would work in this equation. And therefore, any value of y is naturally going to work in both these equations, because the reason why this is true, what it really means is there are infinitely many solutions. That was our third possibility. Okay? Infinitely many solutions. So that's my answer. It's not one point, it's actually an infinite amount of points that would make this true. And why would this happen? Because these two equations right here are actually the same line. If we went through the process of graphing them, you would realize I'm doing the same thing for both equations. They'd have the same y-intercept, they would have the same slope, so they have every single point in common. Every point that belongs to one line automatically belongs to the other. Okay? So again, most of the time, when we're doing these types of questions, I'm going to zoom out here so we can see all four. Most of the time, you get one solution. But there are those special cases where you might arrive at no solution because of parallel lines, or infinitely many solutions, which means they were the same line. And notice in both numbers 3 and 4, after I got to this point, and this point right here where the variables disappear, I don't have to worry about plugging anything back into the second equation because there isn't anything to plug in. I actually wasn't able to solve for a specific x or a specific y to plug back in. So once you get to this step, you're actually done with any algebra. Okay? You're done with any algebra, and you determine is it a false statement, which produces no solution because they're parallel lines, or is it a true statement, which actually means infinitely many solutions because they are the same line. Okay? Now, when you get to your homework, there are 6 questions. I'm just going to warn you, the first 3 questions produce fraction answers. Okay? You're gonna want a calculator with you, and it's gonna be a lot of fraction work. Do not change the fractions to decimals, because some of the decimals are very hard to work with. They're long, irrational numbers that keep going. If you keep them as a fraction, then you should be able to maneuver it across the equal sign and solve for the x and solve for the y. Okay? If you're having problems with the fraction part, make sure that you ask me, okay? And I can help you with the fraction part. But when you get to your answers, you're going to realize, whoa, these are numbers that aren't very nice. And then when you get to the Google form, you're going to be like, oh, wow, okay, these were weird answers. I wasn't doing it wrong. I was actually arriving at weird answers, and that's okay. The last 3 questions, numbers 4, 5, and 6 of your homework, those do produce very nice integer numbers for your answers. Okay? Good luck, and remember, have a wonderful time.